right, back again, talking about reaction equations and how to set them up. We've got to balance these things, and we'll get into the details here. But the basic idea is we can't be creating or destroying mass. And if our reaction equation is written so that it says we're creating or destroying atoms, then it can't be representing what's really going on in reality. So we have to fix that. We got to balance them. So we'll get into kind of step by step how to do this. All right, we got a couple of simulations, or at least one simulation, depending on how I did it this year, that give you kind of tools to practice with this. But I'm going to walk you through just some basic notes and how to do it by hand. All right, let's get rid of my face. Let's take a look. All right. So again, equations have to be balanced to keep from violating the law of conservation of mass. We can't be creating or destroying mass. And if our equation says that's happening, then it's not representing what's happening. Okay, so law of conservation of mass, matter can neither be created or destroyed, can just change forms, right? So we're getting a shuffling of these atoms, breaking bonds, building bonds. The atoms themselves don't get created or destroyed. Okay? Therefore, the mass of the reactants must equal the mass of the products, always, period, full stop. If you say measure the mass of your reactants, then measure the mass of your products, and it's different, well, then some other mass like got away or came in that you didn't keep track of, either in the form of like a gas or something. But you most definitely didn't create or destroy matter in your chemical reaction. Okay, so like if you have 50 grams of reactant, you can have 50 grams of product. Now, the substances that make up that mass can change, but the mass itself doesn't. Okay. Also means you have to have the same number of each atom. So if you have 2 sodium atoms in your reactants, there's got to be 2 sodium atoms in your products. Right, so let's look at the practical aspects of how to do this. So here we have an equation. And I mentioned this before, coefficients are the only thing you can use to balance equations. Don't go changing subscripts. And so you can't change the subscripts. You can't like add a subscript in here. I've seen that happen. Don't do that. Okay. All you can change are the coefficients that go in front of each substance. Okay. So change coefficients to balance subscripts, leave them alone because you don't want to change the substances, just the amounts. So no changing of subscripts. Okay, so the basic steps of balancing a chemical reaction equation. So you write the equation for the reaction. Okay, you might already be given this. Put the symbols of each element in a column under the reactants and products. So we're going to make a little table. Okay. And don't worry, we haven't gone over what polyatomics are, so don't worry about that. Count the number of each atom on both sides of the equation and write it in your chart. Then you can change the coefficients on either side of the equation and balance the number of each atom. Okay. Reduce the coefficients as needed, so you need them in the lowest possible whole number ratio. Okay. So let's take a look at how this works in practice here. Okay. So here we have an unbalanced equation, right? The ions are balanced. We got one on either side, but the chlorides are not. Okay, so let's make our tables. We got reactants over here, products over here. We'll write the substances, the atoms down the middle, the elements. Okay. We're only dealing with iron and chlorine in this one. Then we tally them up. Okay, so how many do we have in our reactants? We got 1 iron in reactants, 1 iron in the product. Okay, chlorine, we got 2 in reactants, 3 in the products. Okay, so we got to fix this. Irons are good, so it's the chlorine we got to figure out what's going on with. All right, so if I add a coefficient up here, a 3, that's going to give me 6 chlorines. Okay, can I make this a 6 over here? Can I make these chlorines a 6 over here? Sure, I can. Just put a 2 there. Remember this; these coefficients are talking about this whole chemical formula here. So we got to multiply it by everything. Okay, so that fixed our chlorines, but now we've got to take into account this 2 on the iron. Boom. So now the irons are out of whack, but we can come over here and fix them by putting a 2 there. Right. So now we're equal on both sides. We got the same number of iron reactants and products, same number of chlorine reactants and products. Easy peasy. Okay. And this is what you have to do. Don't try and balance it all at once. Just pick one element, balance that one, see what that does to all the rest. Pick another one, balance that one, see what that does to all the rest. And you kind of got to chase it around a little bit to find it, but you'll get there. Okay. Now we got to check, are these the lowest, most reduced they could be? Okay. 2s and 3s, yeah, we can't divide that, all those by a number and get a whole number again. So those are the most reduced we can get. All right. Let's do another example. This one we're given a word problem here. We got aqueous sodium hydroxide, aqueous calcium bromide, react to produce solid calcium hydroxide, and aqueous sodium bromide. So here we write it. We got our sodium hydroxide, aqueous, plus calcium bromide, aqueous, yields calcium hydroxide, solid, sodium bromide, aqueous. But now we got to balance this thing. First thing first, let's see if it's balanced to start. Make your table and start tallying these elements. Okay, so in reactants, we've got 1 sodium, 1 of the products. Some of these groups you can keep together too. If they stay together from reactants to products, you can keep them as one thing. Okay, so like this OH, it's the same here as over here. We can keep this together, even though these are 2 elements. They don't get separated, so we can treat them like one. Okay, but we got 2 on products, so that's not balanced. Calcium, we got 1, calcium 1, bromine 2, 1 bromine. Okay, so we got some work to do here. And like I said, you just pick one and balance it. So let's start with the hydroxide, that OH. If I put a 2 on this side, that does throw our sodiums out of whack, but it fixes our hydroxides. So now that we've got 2 and 2. Okay. Well, let's fix that sodium. If we put a 2 over there, it gets 2. This 2 also multiplies this bromine. So looky there, it went ahead and fixed everything for us. And you'll find sometimes that happens. Right? As you're focusing on one element and balancing it, it'll kind of take care of the other ones. All right. And this is kind of the thing, balancing equations takes some practice. And it will get a little tedious. And sometimes you get stuck on one and you start grinding and it stinks. So if you get stuck on one, snag some help or move on to another one. Don't spend 15 minutes just working on one and pounding your head into the ground. Get some help with it. But it can be frustrating. I think of it as a little bit of a puzzle. It's kind of fun to do. That's the basic idea. Oh yeah. Then we ask, are these reducible? Okay. Remember, these are the same as having 1s here. So no, we can't divide these by any number and get whole numbers by any single number. Okay. All right. So that's the basics of balancing chemical reactions, equations. Wanted to give you a little review of how do we tell a chemical change is happening, right? We've gone over this stuff before, but here's some basic science. If we get a release of light, right? Any kind of burning will release light. That's a good example of evidence of chemical reaction. A temperature change, right? If you get a release of heat or an absorption of heat, good indication of chemical reaction. An odor change. So if you're smelling something new that wasn't there before, good indication that's a new substance. Okay? Sudden color change. Okay? Could be a new substance being made. Gases given off. And in a reaction, usually you'll see this as bubbles in your reaction vessel. And then a sudden appearance of solids. So sometimes we'll get what we call a precipitate. You mix 2 liquids together, and you'll see this. We're going to do at least one lab where you'll see this happen. Mix 2 liquids together, boom, all of a sudden you got a solid that's in that solution. Okay, so also a good indication of chemical change. All right, so that's the end of the notes for this lesson. should have a good handle on how we're going to represent these chemical reactions with equations, how to balance them, what they're good for, and how to use them moving forward, because we'll be using them a lot. All right, here we go.